All right, welcome back to part 2 of solving linear equations. So we left off with, we were starting to solve linear equations with fractions and decimals, and then we're going to get into some where we have parentheses. So let's go ahead and get started with the first one that has fractions in it. So just like the one we did before where we actually solved it, just to recall, just like the one we did, the previous one from the previous video where we had variables on both sides. We got the variables, all the variable terms on one side, all the constants on the other. We're going to do the exact same thing for this next problem. The only difference is that they were all whole numbers in the previous problem, and this time there are some fractions. So just like we did before, I'm going to highlight where my variables are. Just to kind of keep us honest on where everything is and remind ourselves. And I'm going to circle my equal sign and draw my imaginary line. So now I'm going to get one of the variables over to the other side. I'm going to get this 1/4 x over to the other side, but you could also get the 5/4 x over to the other side. So whichever one you prefer, I'm just going to do the 1/4 x. And I'm going to get it to the over side by subtracting because I want to create that additive inverses. And since it's a positive 1/4, I want to subtract 1/4. So that would end up canceling. Now I'm just going to kind of up here on the side remind us what we're doing here. We have 5/4, and I'm just looking at the fractions. I'm ignoring the variables, minus 1/4. In order for us to be able to do a subtraction with fractions, we need the denominators to be the same. And luckily for us, the denominators are the same. So all we do here is subtract the numerators. So 5 minus 1 is 4 over 4. And that, ladies and gentlemen, simplifies to just 1. So that was a lucky coincidence for us. So now I just have plain old x plus 6 is equal to -2. Now, didn't that work out really nicely for us? Now we want to again isolate the x by subtracting 6 on both sides. So it's exactly what I'm going to do. And I'm left with x is equal to -2 minus 6, which is a -8. And again, we can check by plugging in the 8 back into the original equation. Just for time's sake, I am not going to do that. If you want an example on how we actually were able to do that, please go back to video 1. Let's move on to some decimals, okay? So again, just like we did before, I am going to highlight what we need, which is, or what we have, which is the x's on both sides. And then I'm going to circle where my equal sign is, and I'm going to create that imaginary line that helps us keep our lives organized. So again, we can get either the 7.8x over to the other side or the 5.4x to the other side. Now, I always try to have positive coefficients, which is why I always subtract the smaller coefficient to the other side. Now, this is what would happen if, say, for example, you did not do that. So let's go ahead and subtract that -7, or subtract the 7.8. Sorry, I need to scroll up a tiny little bit because if not, things start to look a little messy. So -7.8x on both sides. So this is what happens. That cancels, which is what we want. We created additive inverses. So now I have 4 is equal to, and I'm going to have 5.4, and I'm subtracting 7.8. which gives us a -2.4x minus 8. So now I have a negative coefficient in front of the x. Does that change our lives? No, not really. That just means to say we need to keep in mind that we have a negative, and so that might change things in the sense that we have to remember to multiply or divide by a negative number. That's the only difference. so keep in mind, whether you end up with a positive or a negative coefficients, it's really not going to matter in the end. Okay, you're getting to the same answer. So now I'm going to add 8 to both sides, and the reason why I'm adding 8 is to isolate the variable term. So 8's cancel. I have 4 plus 8, which is 12, is equal to negative 2.4x. And then since the negative 2.4 is being multiplied with the x, I'm going to divide both sides by negative 2.4. Okay, so now I am gonna use a calculator here. I am going to do that calculation there. So if we were to divide 12 by negative 2.4, and I'm just going to do it here to the side, I'm going to end up with a negative 5 is equal to x. Okay, so that kind of worked out nicely in the sense that we ended up with the whole number. All right, so our answer is negative 5x. So once again, if you want to see how we actually check to see that that is how we do it and to check the answer, please go ahead and watch video 1. So now we've gotten to the part where we have parentheses. Now there's a couple of different ways in order for us to be able to do these problems, okay? I'm going to show you both ways on how you can tackle parentheses, okay? I will start with distributing. So that's what I'm going to do first, okay? So with parentheses, we really want to get rid of any kind of parentheses there. So I'm going to take this negative 6 and I'm going to distribute it to everything inside my parentheses. Only inside the parentheses, we're using the distributive property. So we have negative 6x minus 18 is equal to 24. And now this problem looks very similar to something we have solved for before. So I'm going to add 18 to both sides. We have, let's see, 24 plus 18, that is 42, is equal to negative 6x. And then we're finally going to divide both sides by negative 6, which is 7. So x is equal to negative 7, and that's our answer. So that's the first way you could potentially do this. The second way you could do this is, if I'm going to look at the next example, and keep in mind that that's a negative, but really it's a negative 1. We always pretend that there is a 1 there, even though we don't see it. It's like an imaginary friend. We know it's there. So I'm going to take this negative 1, and because really what this is saying is negative 1 times the quantity of y plus 8, we want to undo order of operations. That's the second way of doing it. So instead of multiplication, what undoes multiplication is division. So I can divide both sides by negative 1. That cancels, and I'm left with y plus 8 is equal to negative 2 divided by 1, which is a positive 2. So that's another way you could potentially do this. And notice it does work for the previous problem. I could do negative 6x plus 3 is equal to 24. I could divide both sides by negative 6. 6 cancel, that becomes positive. I'm left with x plus 3 is equal to a negative 4. And I would just subtract 3 then to both sides, and I'm going to end up with the same answer, which is negative 7. So here we see that it doesn't matter. You end up with the same thing, regardless of which method you use. Okay, so just kind of wanted to clarify that. Now, in order to solve the y plus 8 equals 2, I'm going to subtract 8 from both sides. So y is equal to a negative 6. Okay. Now, fair warning, the only way this is going to work, the second method, is making sure that the coefficient, so like the part outside of the parentheses, is able to divide nicely the constant on the other side of the equal sign. If it does not, I would use the first method, which is just simply distributing out that number in front. Okay, so keep that in mind. That's my little warning there. okay? All right, so now we have quite a few things going on here. So I have to solve 5 parentheses, a minus 3, close parentheses, plus 5 is equal to negative 10. Now I could divide both sides by 5, but then we're going to run into some issues because it's not just the 5 and then the parentheses. We have another term to it. So in this case, just like before, we're going to have to use the first method of distributing that 5 out. So that's what I'm going to do. 5a minus 15 plus 5 is equal to negative 10. And then I'm going to combine my like terms. We have not seen that before. I can combine the numbers together to make my life a little bit easier to deal with, which is going to end up with negative 10. So is equal to negative 10. And then I want to isolate the variable by adding 10 to both sides. And look what happens. Both sides end up, the negative 10s end up canceling. So I'm left with 5a is equal to 0. I still have to divide by 5. But what that means is that a is equal to 0. And that is a perfectly acceptable answer to this problem. Okay, so again, go back and check to see if you if something seems kind of fishy, you can always check back to see. And again, reference video 1 for that. So for this next one, again, we have some other stuff going on. So I'm gonna go back to the first way that we solved by distributing. Okay, so I'm gonna have 2/3, and I'm gonna do this to the side here just to remind ourselves how to actually multiply. So 3 goes into 6 2 times, and 3 goes into 3 once. So I have 2 times 2, which is 4. So I'm going to have 4m, and then we can do the same thing here with the 3. So I have 2/3 times 3. 3 goes into 3 once, 3 goes into 3 once. So this ends up just being 2. So minus 2 is equal to 8 minus m. So now what I'm going to do is I'm actually going to add m to both sides, because then I end up with a nice positive coefficient. And then I'm going to add 2 to both sides. And I'm running out of space here, so I have 5m is equal to 10. So I divide both sides by 5. So that cancels. I have, I'm bringing it up here, 5m is equal to 2, because 10 divided by 5 is 2. Okay? All right, last set of examples. So here, you can do a couple of things. You can first subtract the 8, which is actually what I'm going to do, just to make things a little bit less confusing for me. And then I'm going to distribute the negative 2 out. You could, if you wanted to, actually we've been doing that a lot. Why don't we instead, can I divide both sides by negative 2? Why, yes, I can. I absolutely could do that. The 2's cancel, the negatives become positive, and I'm able to divide that negative 8 by 2. So here's where dividing first would actually work out. Could you distribute? You absolutely could as well. So again, there's more than one way to get to the same place. I'm going to subtract 5 next. 5's cancel out. I have 3y is equal to negative 1. So y is equal to negative 1/3. I'm sorry, divided both sides by 3. Kind of skipped a step there. I apologize. Okay. So that's this next problem. Now here, notice I have 2 sets of parentheses. I'm not going to mess anything up by trying to get these constants over to the same side. I'm actually going to just take away the parentheses first. So I'm actually going to distribute both sets of parentheses. So 4x minus 4 minus 2 is equal to, and I distribute the 5. 5 times 2, 10x. 5 times 3, 15. plus 6. So now look at all the different things that I have going on. So I'm going to